All right, something important in statistics is standardized scores. So, like for example, I think the lesson has a really good lesson on which score should she use. Should she use her ACT scores or her SAT scores? Okay, so in order to explain standardized takes something and just makes it standard. So we call that the Z-score. Okay, and the Z-score is going to be the actual minus the mu. Okay, and then you're going to divide by sigma, and that is going to be okay. So that's for the actual stuff. So that's a population. So that's a population type of setup of a Z-score. Now, if we wanted to do a sample Z-score, it would be X minus X bar, okay, and X bar is obviously going to be the mu, or the mean, divided by S. So just it depends on what sample and stuff you're working with. Okay, so now Z-scores help you take something and put some context to it within relation to all of the numbers. Okay, so let's say that Mr. Devaney earned a 1400 on SATs but a 30 on ACTs. Okay, so those look pretty good. You're like, oh man, well, 1600 is the max on SATs and I believe it's 36 is the max there, but how do I compare these two? Which one's really above normal? So for that I need to know the mu. So in this case, Alt 230. Okay, I need to know the mu, and I also need to know the sigma. Okay, Alt 229. Okay, so I need to know those, and I need to go through them. Okay, so the average, let's say, was for SATs was. You know what? I'm going to use the information that was in that one thing. Hold on. Because I like to use as close to normal numbers as possible, because when you do that you just tend to really make your job a whole lot easier. Okay, so the mean score would be 1059. Okay, and the standard deviation would be 143 and this is SATs. Okay, and then ACT, the mean was 26.4 and the standard deviation would be 3. Okay, so let's use the numbers from the actual problem. Okay, so Mr. Devaney earned those scores. First off, that's not very good. Well, that's probably pretty good. Okay, but how good are they if I compare the two? So what this does is this takes. Now here's an interesting thing. You need normalized data. And normalized data is usually like heights, weights, test scores, all that stuff. Because if you use normalized data, this stuff makes sense and you can compare between two different categories. So that's what we're doing Z-scores for. Okay, so the formula is you take your actual score. So I'm going to take 1400. I'm going to minus 1059. Okay. And I'm going to divide that by the standard deviation, which is 143. So I'm taking the differences between my score and the mean, and then I'm dividing by the standard deviations, and I should get a number that relates to Z-score. And then I'm going to do the same thing here. So I take my score of 30, and I minus 26.4, okay, and I'm going to divide by 3. Okay, and if I use my calculator, okay, I go 1400 minus 1059, and then I divide that by 143. Okay, I get this Z-score to be 2.38 if I round it to the nearest hundredth. You can round it a little bit more or less. I'm just going to round to the nearest hundredth. And then 30 minus 26.4 divided by 3. Okay, and this z-score is 1.2. Okay, and as you can see, if I look at this, in the beginning it was kind of hard to tell which one was which, but I can see obviously that compared to the rest of the people, my z-score is higher, so therefore my SATs are higher in comparison with everyone else, as opposed to everyone with relationship on ACTs. Even though there's less of a point differential between the 30 and the 36, on average, you know, just looking at these numbers and working with it, I can see my z-score is way better. It's almost twice as better as I did on my ACTs. So I should definitely use my SATs when going to college, because I'm going to be better than a lot of people. Now, if I wanted to use my information and go across to it, here's a cool thing. I can go to my table, okay, and mine was at a 2.38. And so that's right here. Okay, 2.38. It's more right here. Okay, so how much better am I than the rest of the population? So if you remember me talking about normal distributions, I have to add up all the numbers to the left of it. So in this case, I could take it from 100. I could take all the numbers on the right from 100 and subtract them, and I would get an approximation of how much better I am than the rest of the population. And so I take it, I'm going to say, let's say I took off about 1.5 here, so that leaves about 0.2 here. 0.5 is 0.7, so this is 0.8. So I'm better than 99.2% of the population according to my z-score for SATs. All right, now if I did ACTs, that would be over here. And so I would take off of this chunk of 100%, and that would tell me how much percentage I am better than the population. And so I'm going to do a guesstimate. I'm right about here. I'm really doing a rough guesstimate. I'm going to say about 5 right here. Okay, so that's 4.2, 8.6, 8.6, 10.3, 10.8, 10.9. So over here, my ACT score is only better than about a little bit under 90% of the population. Okay, so it's really, or 89.2% is what it's better than. So as you can see, you know, just looking at the bell curve and what the normal distribution be, mine looks really good in ACT compared to SAT. And yes, there is a huge difference. Now, if I was at a negative 1.5, I would only be better than 4.4 plus 1.7, which is 6.1. 6.6, 6.7. So I would only be better than 6.7% of the population. So when you're looking at z-scores and you're checking out the probabilities or the percentages you're in, okay, when you're over here, subtract this number from 100, and it's easier. And when you're over here, just use this percentage and don't subtract from 100, and you'll be fine. And that's how I do. That's how I work with the standardized scores. Okay. But that's pretty much it for standardized scores. I hope you guys enjoy, and I hope you guys understand. Have a good day. Bye.